One of the most spectacular breaks in the McDonnell Ranges is Standley Chasm, just out of Alice Springs in Central Australia. To give you an idea of how narrow and tall the chasm is, imagine that you're walking down one of the narrowest streets in a city such as New York, London, Sydney, Adelaide, or anywhere else. Imagine you have 30-storey buildings on each side of the street, and then suddenly you shrink the width of that street to about a quarter of what it was before. Then you have an idea of what it feels like to walk down Standley Chasm. Millions of years ago, the whole of Central Australia was covered by ocean. Sediments fell down to the ocean floor, layers built up and eventually turned to rock. That used to be the ocean bed way up there. Well, some of the rocks formed cracks. Water seeped into the cracks, washed away some of the fragments, and the cracks widened and eventually became Standley Chasm, which is so spectacular, particularly around noon, that people come from all over the world to see it. It's so narrow and so deep that the sun only penetrates for about 5 to 10 minutes each day. First of all, it sweeps down the western wall with a blaze of orange-red colour, then across the floor of the chasm, and then up the eastern wall. And this, Standley Chasm, is just one of the many breaks in the McDonnell Ranges.
Well, water is pretty soft stuff, but given enough time, water can wear away the hardest of rocks. That's what it's done here. There's not much sign of the river that flows along this riverbed. There are only a few pools left, but it's chewed away for millions of years in the torrents that occur at flood time, and it's cut this lovely place, Simpson's Gap, not far from Standley Chasm. In a sense, it's like the chasm. A thin gap will eventually be worn away by a river, and it'll make a bigger and a bigger gap, and the famous gap that characterises Alice Springs was cut this way as well. As the water's poured through, it's chewed away at the ancient seabeds, and you can see them on either side, exposed now as once they lay. Layer upon layer of it, now slumped slightly to one side because of the movements of the Earth's crust. And if you look up there, you can see under the ledges characteristic ripples. That's actually fossil ripple of the old seabeds that once lay here under the ancient seas.